Hello guys, welcome to this video. I'm so excited to have you here and to do this once again with you. It's Bright from B-Wave ICT, and today we are going to be talking about functions in C. So we are going to be looking at our nested loops and functions, 0x02 project to be precise. And you know how we do it here. We are going to explain the quiz as well as some questions to help you get grounded. Then I'm going to allow you to do the rest by yourself with the basic information, the best information you can get about this project from a peer at this time. All right, so let's get started. First of all, the quiz and then the explanation to the quiz. Then we'll get into the tasks. I'll cover a lot of them and then the explanations to these tasks so that you understand what we are doing. You are able to do it confidently, beat the checker, do it in line with your first deadline, and everything you need to succeed right here in this video. If you know you get valuable content from me, kindly like and subscribe. Okay, straight to the point now. First off, the quiz questions. So question 0, which of these loop statements don't exist? In the last video, I did tell you about the loop statements in C, where we have the for loop, we have the while loop, we have the do while loop, but we don't have a for each because a for loop is basically looping through each character. So there's nothing like a for each because that's the for loop. We don't have loop 2. So we don't have loop 2 there, and we don't have each as a loop because loop basically goes through each character. So which of these loop statements don't exist? For each, loop 2, and each. They don't exist in C. Question 1, what's the ASCII value of A? All right, so what does this mean? And the ASCII here, what are we trying to say here? I know it could be quite confusing when you see this ASCII value, but simply what ASCII means is the integer value of a character. All right, so you already know by now that A is a character, right? ASCII simply means the integer value of the character. You know what an integer is? An integer or number. So when we say ASCII value, we are simply saying what's the integer value of this character. So integer equal to whole number, and then when we ask for character is a letter, right? So if we have 85, you know that this is an integer, right? Then if we have A, you know that this is a character, and then this an integer. So when you see ASCII value, they are simply saying what is the integer value of this character, and the integer value of the capital A. You know, programming and C generally is very case sensitive. So what's the ASCII value of the capital A? Well, it's 65. Right. Now the question 2 says what's the ASCII value of small a, this small letter A here, and it's 97. So between 65 to 96 are the ASCII values of A to Z in capital letters. And then 97 upward gets us the ASCII value of the lowercase letters. So what's the ASCII value of J? Right, this is capital J now, and it's 74. Okay, now 74, that's the ASCII value of the capital J. What's the ASCII value of 0? It's 48. So 0 also has an ASCII value, and that is 48. What's the ASCII value of this minus sign? The ASCII value is 45. And then question 6 says, what's the ASCII value of 5? That's 53. And then So now you know what an ASCII value is, and these are things you could just look up in your resources, or you could just check for it on Google and you'll get them. Question 7 now is a bit tricky. What's the result of 12% stage 2? So it's something I'll be explaining more in my special intense learning class, but just to give you an hint, this means a modulus operator, and it's not actually a percentage. So this is not like 2% of 12. No, 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 no. This, in programming, this sign here is a modulus operator. So what this question is asking is, if 12 divides 2, what will be the remainder? All right, so that's the whole essence of this question. So you could just change it to, what's the remainder of 12 divided by 2? And 12 divided by 2 is 6, it would give us 6, no remainders. So the answer is 0 because there are no remainders. What's the result of 12? What is the result of 12 modulus 3? So this question, the same thing, you just change it in your head to, what's the result of, what is the remainder of 12 divided by 3? And nothing, because it will give us 4, no remainders. Now, if you understand those previous two questions, you get this immediately. What's the result of 12 modulus 10? So if 10 divides 12, what will be our remainder? We'll have a remainder of 2, and that's that. What's the result of 89 modulus 7? What's the remainder if 7 goes into 89? Would have a remainder of 5, and that's that. Now, these quiz questions were simple, right? Very, very simple. And functions and loops in C is a very simple topic, actually. All right, so now you have a good grasp of the C quiz questions. I have another video, a very short one, less than 2 minutes, where I just answered all the quiz questions. The link is below if you want to answer the quiz questions immediately and get started with the task. Okay, now task 0 is where we are heading to. But before we go to task 0, shall we look at our requirements? All right, so let's look at our requirements for this task. Our general requirements is that there should be a README file at the root of the folder. Our code should use Betty style. We are not allowed to use global variables. We know all this. Now, look at the new requirements we have. The prototype of all your functions and the prototype of the function putchar should be included in your header file called main.h. And then don't forget to put your header file. So for this project, welcome to creating header files where you put your prototype. If this looks complex and vague, don't worry, I'll break it down and explain it in a way you would understand. So let's have this at the back of your mind that we have two new requirements, and this one is usually you already know about that one. So let's go to the task now and see how we use these two new requirements to help ourselves. All right, it says, the first question says, write a program that prints putchar followed by a new line. Okay, so we want to print putchar and followed by a new line, and then our program should return 0. So let's get onto it. We are going to print putchar, and you know, this word putchar is actually a very interesting word. In fact, it's a function. And guess what? We are talking about functions in C. Putchar is a function that writes a single character to the standard output. It has its own syntax and it's writing a single character like A, B, those are single characters. It writes them to the standard output. So we are going to use putchar now to print all these single characters. This as a single character, this P as a single character, we're going to use putchar to do just that. Let's go ahead and do that without wasting any further time. So in my terminal here, I'm going to cd into first of all, I want to ensure I'm in the right place. So I'll list out what I have. And now you can see the repo we are working on, ALX low level programming. So I'm going to seed into ALX low level programming. And in here, I list out what I have. You can see my previous two projects are there, plus my README file. So I'm going to come here now and see the directory where I have this project, and you can see it here, 0x02 functions. I'm going to copy this, and so I can use the mkdir command to create a new directory, and and let me clear all of that. So mkdir, let me copy it again. Seems like I copied the wrong thing. That's why I got that weird looking error message. Paste. And now when I list out what I have, you can see my new folder here. So I can simply seed into 0x02 functions and nested loops. I'll clear what I have. And in here, the first thing I want to create is a README file. So let's do that now. README file. It seems my terminal window is looking too big, so let me lower it a bit. I actually increased it so that you can see my screen very well. And okay, readme.md file. And in my readme.md file here, I'm going to press I to insert. Then I could describe what each script is doing in the repository. So you could take your time to do all of that. I'm just going to put 0 puts char. So you could write any description that it's fitting for you. I'm just going to do mine quickly. All right, so now I have my README file, and now I can now go back to my tag 0. Write a program that prints puts char followed by a new line. Now let's go back to our requirements, and in these requirements, look at it. The prototype of all your functions and the prototype of the function puts char should be included in the header file called main.h. So tag 0 tells us about this function puts char. Now, if you go back to the requirements, it says the prototype of this function puts char should be included in our header file. So let's go ahead and write the prototype of our function puts char in our main.h file. So the very first thing we want to do is to create a header file called main.h. Let's go back to the requirements. So should be included in your header file called main.h. In this main.h, we are going to write the prototype of this function puts char. I hope that's clear. So let's go ahead and do it practically. Back to our terminal window. So I'll use vi to create a header file called main.h. Now, in a header file, we have to write some codes to actually tell C that this is a header file, some standard codes to tell C that this is a header file. And the very first one is this syntax. If ndef, and then what's the name of our header file? Main h. So this is the name of our header file. I'm going to write that in capital letter. Then the second syntax is going to be define. So this header file is going to define every function in our main.h. And so these two are the default syntax. if ndef and then define, we must put them in our header files as the general way to write header files. And at the end of the day, we are going to close with this syntax that says ndif. You can see it's actually something that C and our terminal knows, because once I put the F here, you see the color changes. So these are just syntaxes that you could go look up later or could just be comfortable with them. But for now, this is the syntax to write and define any header file. Anything you put in here now could be prototype or prototype of functions that you will need. So our header file, remember that by default, we have this header file. I hope you can see my notepad now where I do my whiteboard stdio.h. Remember, by default, you have this header file that brings in the standard library and the basic functions you need, right? By default, you have this. You always include this. Now, when you do the include, I'm sure you can remember all of that. This is the syntax to get your header file normally. But now what we are doing is that we are not using the definitions in this header file. So this is a header file .h. All right. We are not going to use the definitions of this header file. Some of the definitions of this header file includes printf, quotes, you know, you are used to this from the previous projects. Now we are not going to use any of these definitions because we are creating our own header file. And in this case, our header file is main.h. So all the codes you see here now is a way for us to create our own header files. Now the header file doesn't look too complicated for you, right? We have been using the default one, but now we are creating our own. That's just the difference. All right, now we are going to define, let's go back to the question. The prototype of all our functions and the prototype of the function puts char. And in tag 0, we are using the function puts char. So let's go ahead to define the prototype of the function puts char. So the function puts char has this syntax. You do int, then puts char, and then you go ahead to write the character you want to put and its value. You say something like character and then maybe G or C or anything. But in our case, look at what we are going to use. In our case, we are going to use this function that has been given to us here. I'm just going to copy this now, copy that, and come here to our header file now, int puts char. And in our puts char, we are going to character C. So this is our prototype for our first function. And we will now be using this header file to access this prototype for our code rather than the regular stdio. So let's go ahead and do that so that you understand what we are saying. So when I list out what I have now, you can see I have this file called main.h. Now this is very important, and I have my readme file here. Now I can create my tags 0. So once again, tag 0 says the file of tag 0 is 0putchar.c. So I'm going to copy that and create it. But you know the regular way I create my files, I create all of them in one command. So I'm just going to do that too. So 0putchar.c, I'm going to copy that, paste. So if you're following me to create all your everything in one command, you will see that this is usually way easier. So I'm creating file 1 now. Paste. Go ahead and do file 2. File 2. Paste. Go ahead and do file 3. Paste. File 4. File 5. So there are quite a lot of them, and I would have fast forwarded this video, but in case this is your first time seeing me doing it, I just want you to have a good idea of what I'm doing. File 5. So file 6. So you could go ahead and create all your files just like this. I'm pasting it on my notepad here. So I just copy and paste into my terminal at once. So you could go ahead and create all your files down to the advanced tags, file 11, whatever file you like, up on until the advanced tags. If you wish, you can open your advanced tags to create the files, but I'm not going to do that. So those 6 files are enough for now. And let me look at my file 6. So with those files that are enough, I come here, I could copy all of that now. Just copy it, come to my terminal now, and if I list out what I have, you see I have only 2 files, but when I paste what I've copied and press enter, now if I list out what I have, you see I have a lot of files. 0, 1, 2, 3, 4, 5, 6. So you could go ahead and create your own up to the end and copy all of them. I just did mine so that this tutorial could be short for you watching it. Now let's go back to our file 0, and our program should print this followed by a new line. Remember, we've already defined the header file for this program that we want to print. And so what's next is that we go ahead and go ahead and do the tags. Now vi0 puts char as our first. That's our first file. Now remember I told you that when you are using C's header file, the default one, the one you've been using since, you do this, right? To include your stdio.h, you include this header file. That's already default. C already understand this. But in our case, today we are not using any of these components. So we were not going to include this header file. We have our own header file called main.h, and that's what we are going to include. So it's pretty much straightforward. Here we come and write include. And here, rather than use this, we are now going to use a double quotes and say main.h, which is the name of our file. Just like this, we've included our header file. All right. Next up, we want to give our code a proper documentation so that Betsy does not complain. And how do we do that? So your double asterisk here, come down. The main function of this program is to print puts char. Now, this program is is written by well, that's a popular name, bwave. So, and then we have to give it a return value. Return. So what's our program going to return? According to the instructions, our program returns 0. So I'm going to come here, our program returns 0, and comment out the code. So this is for Betty now, and you could go and make your code neat. You could come here and press enter, or you could leave it like this. So have fun trying to explore things. Then we'll come down now, and as usual, int main. Our main function is void, so void. Then we'll come down now to write our code. So we've defined the function puts_char in our header file. If we are going to use the normal puts_char function, you will do something like char, maybe ch, standing for character, or whatever you like. Then you come here and you put the character. Remember the first character we are going to print out. The first character is this here, this sign. So you are going to print out that, give it a value like this. That's in the normal puts_char method. So you're going to do this. Then you come down and you'll now say puts_char. You will now print ch. So what this program is going to do in its normal sense is going to, when you print ch, this ch now is going to print out the character that you've listed here. All right, now this was if we're using the normal stdio format, we do all of that. But now we are not using that syntax because we've defined our own header file. So you see how powerful a definition of a header file is. And in our header file, remember what we defined in our header file. In case you've forgotten, let me show you again. So I'm going to save and quit VI just to show you what we defined in our header file. Look at what we defined, this parameter here. And we've used this parameter to cover, you remember when I said if we are using the stdio, we are going to do something like char, maybe c, then equal to, and the rest of them, right? Now we've used this parameter here, int puts_char, just this puts_char function here, to save ourselves all those stress of going through the normal method. So all we are going to use is this function that we have defined here. This function is not known to C, but since we've defined it in our header file, we can go ahead and customize. So you're not just learning C, but you're learning how to create your own header files and how to customize like a boss. So let's go back to our tax 1 now, tax 0. And in here, we are now going to use what we've defined so far. And that is puts. So that is puts_char. Now we are now going to print out the character we want to print out, and the character is this. All right, see it here. Look at the first character we're asked to print. You know, the puts_char function prints each character, just one character, and then the first character we are printing is this. The second character is P, the third character is U, the fourth is T. So we printed this P. Now we'll come down and print the, once again, we use the function we've defined, puts_char, and this. So we are going to print P next. Remember, the function puts_char takes in only one character, and that's what we are doing. So with these two now, you can go ahead and print out the rest, right? If you can print out the rest on your own, great. If you can't, let's do it together. But if you can print out the rest on your own, I want you to pause this video and print out every other character for this tag 0. Then come back to this video and see if you did the same thing I did. So I'm going to just continue to paste them now, because you already understand why I'm doing this. So all right, now I'll come here. We are to print puts_char. So here, instead of P, I'll write U, and then I'll write C, and here will be C, H, A, and R. All right, if you did the same thing I did, congratulations. It means you just understood the assignment. Okay, so it's as simple as this. And now they said we should, after printing puts_char, we should follow it by a new line, and our program should return 0. So you know how to print a new line already. So let's just go ahead and print out our new line. Our new line character, you know how to do that. We use the escape key, which is this slash here, and N. So this is going to print out the new line. And lastly, return would be 0. And now we can cover our code. Okay, so that's basically all. We're asked to print puts_char followed by a new line, and then our program should return 0. So let's go ahead and save this now. And you know what we should first do? Check for Betty, if Betty has problems with her code. So I ran this and no problems with our code whatsoever, no trailing white space, no indentation error. If you have yours, I've explained it in the last video how to fix it, so it shouldn't be a problem for you. So after checking for Betty, we go ahead to add. Now we want to commit, we want to go and check if our code is correct. And with the message, maybe tax 0. And go ahead to push to GitHub. All right, let's check if we've done something nice now in our 0 puts_char. So check our code, start a new test, and let's see what we got. All right, so we are successful, and I hope you did understand what we did. So we use the puts_char function to print a new line, and then we define our prototype in the main.h file. Now let's go to question 1, task 1, that says write a function that prints the alphabet in lowercase followed by a new line. We are going to use this puts_char twice in our code. Now we are given the prototype of the next function here, and it would be void print alphabet void. So how are we going to make the most out of this head prototype that we're given? Well, if you remember, we are going to just copy this prototype the same way we did with the puts_char, and we are going to put it in our main.h file. So let's go back to our terminal, clear. Now I want to vi into main.h, and this is our first prototype. So the second one is going to be this. All right. So this first one, we had an issue where I'm supposed to put a semicolon here. So I just did that. So you want to do that with your first prototype, if to avoid any kind of issues. In case you got an issue, do this. Don't forget your semicolon here. Now this is our second day, so I'm going to quit now. And so that's what we do with our header file. Now to explain what I just did there, let me open my main.h file again. I love the explanations because that's where you learn. Now this prototype, we got it from ALX here. We didn't have to stress ourselves. And this is going to be the definition we are going to use. All right, so we'll not need any of the stdio standard library because we got our own prototype. All right, I hope that's quite clear now. Save and quit. There was something I didn't do to my main.h file. I did not check for it with Betty. And you can see no errors whatsoever in my main.h file. So I can now move on to vi tax1. And let's go back to the question now. It says, write a function that prints the alphabet in lowercase followed by a new line. So we want to print all the alphabets, in lowercase, and then they will be followed by a new line. So here's where you need your thought process now. How do you print the alphabets in lowercase followed by a new line? What can you use to print all the alphabets? Now, there are a couple of ways you can do that. You could come here and start writing you could come down here and write print a, and then you put your new line and you pretty much close it, or you could go and write, then after writing this, you come again, you do the same thing, B, C, D, up until Z. But this won't work because we are not using our printf. And so that's totally out of the way. Now, in your thought process, start thinking, what can I use? This is a good idea of what you can use. What are you learning for that day? What's this tax all about? It's all about functions, right? Now, what have you learned before? You've learned about loops, right? And now in this task, we're talking about loops too, while loops, functions, and then you've learned about loop. So why not use a loop to print out all the alphabets? Remember what a loop does. It goes through every alphabet, everything. So if you write a for loop, you write something like this, a for loop, if you write a, yeah, then you come down and put a for loop for a. Now, anything you write inside the for loop is going to basically loop through or go through everything. Let's do it with a real life example now with our tax 1. So for example, how do we do a for loop for this tax 1? Write a function that prints the alphabets. Now, what are the alphabets? A to Z. All right. Now, let's write a function that prints an alphabet and then followed by a new line. And here we are told to use putchar twice in our code and not more than twice. Okay, so I'm going to do this. First, I've defined my prototype. Then next up, I'm going to come here. And you remember how the first thing to do is to include our header file. In this case, we are not using the stdio because we have our own header file. So use main.h. And once again, to avoid Betty problems, we have to give it a description. And the description is that we are going to print, alphabets. And we are going to print all alphabets in lowercase. All right, and then followed by a new line. So that's a pretty much decent description for it. And then are we giving a return value here? Not much, so I can just keep that for now and come down. And so what would I use now? Remember the prototype I have the void print alphabets. So rather than using my int main, I'm going to use the prototype I already have from ALX. I'm going to copy this now, copy and paste. Right now, I'm going to come down. So this would replace the regular int main void because I have my prototype given to me by ALX. Now it's time to do the tags. We want to print out the alphabets in lowercase. So first of all, we define a variable and assign something to it. So we have a variable called letter, and it has the character. It's a character basically. This is going to be a character string. I'll be explaining more about that in my C from scratch tutorial about character string, and then the difference between single character and character string. We'll talk more about that. But for now, I want to define this variable later and assign it to a character. Then we are now going to use our for loop to simply say for the later, this is our variable called later. First off is set to what's the first alphabet we have. The first alphabet we have is A. So I'll say for the character A, for the letter, and the letter is set to A. Now I've set this letter to A. That's what this line does. I'll come down here and say the letter, which is set to A now. And remember, this letter is a character, and this character is A. For this letter, as long as it is less than or equal to another letter called, so what's the last letter we can print? Z, right? So as long as this letter A is less than or equal to Z, it's going to do something. Letter plus plus. You know what this does? This means increments it by 1. So this is what it's going to do. Now let me take it away from this VI environment and show you in the whiteboard here. So this is what it's going to do now. For letter A, as long as this letter is less than or equal to Z, it's going to increment. So it's going to check letter is originally A. Now it's going to check, is A less than or equal to Z? Yes. Once it says yes, it's going to now increment this A by 1. And if A is incremented by 1, A plus 1 would be what? It's simple now. It will be B. So this A here will change to B. Is B less than Z? Yes. It's going to increment the B now plus 1, which would simply give us C. Is C less than Z? It's going to yes. So it's going to increment plus 1 until we get to Z. Is Z less than or equal to Z? Z is equal to Z, so it's also going to print out Z. So after it's reached Z, it has gotten to this parameter. As long as the letters is less than or equal to Z, it's going to print out each of the letters. So that's how it would get what to print out, and it's going to print it out well for us. Now, you understand better what a for loop does, right? It goes through each character. It iterates over and over again. It's looped through them. So it jumps through each of them. A less than Z, increments, come back, till our loop is completed, and then the program will stop. With that definition now, so for the character A, as long as A is less than Z, continue incrementing. Remember, we are printing all the alphabets in lowercase, and that's why I didn't use capital letter A. You know, if I were to print it in uppercase, I would use capital letter A. But since it's in lowercase, I use capital letter small letter A. Now, after printing this now, what's the next thing I'll do? See the next requirements. We should use put char twice in our code. So I'm going to do just that now. And how do I introduce put char here? Okay, so I'm just going to do this. Put char. What does our put char do? Remember, it prints out each single character. So it's going to print out A as a single character, B as a single character, E as a single character, till Z, just the way we are asked to do. Print all alphabets in lowercase. I'm going to now do this. So this is going to print each single character. Put char later. Remember, we've defined our put char in our main.h. So once we call it anywhere, it's going to answer us and reply. Now, after that, the next thing we want to do is, let's look at our requirements. Now, followed by a new line. So we print out all the alphabets using our for loop in lowercase. I've done that. We want to follow it by a new line. So I'm going to use put char to do just that. So I'm going to say put char, you know, and that's our escape key. So yes, so you know what this does now? This print out a new line for us, right? Let's make our code beautiful with good spaces. So now it's looking better. Put char, yes, this is the function that's defined, and then I can come down and close up my curly braces. So this is clear now. We've used our for loop to print out all the alphabets in lowercase, and then we've used our put char to print each single letter, and then our new line, we use our put char to also print out a new line. Now I can save and quit. So I can use Betty to check if I have errors with my coding style, and let's see. Now you see I have errors. I have about 2 errors, and the first error is that it's a trailing white space, so that's an error. And then there's a warning. There's a warning there that's given to me in my line 7. So let's go fix that out now. I guess some of you did notice the warning, that this would give me a warning because of the way I actually wrote my code. So let's go fix that now with Betty. The first error is in line 13. The second is in line 7. Now let's check line 13 first, because that's the error that is showing in red. So I'm in line 15, 14, 13. So I have a trailing white space, and you can see the white space. You see how my cursor is moving? This is the white space. Now my cursor doesn't move again. You can see it. And then our next is in line 7. So it's saying no description found for this function. So in case you're wondering why I didn't use function main, like why here I did not use main, remember what's our function? Our function is print alphabet. All right, so that's what I used. And then we have no return value, so no need to put in a return value here. So all the function I need now is to just print out the function main. So why is it saying no description? It's probably because of this grammatical error I have here. Here it says print alphabets, but here I'm using an L. Here no L. So let me remove that now. So it's exactly the same thing. And so let me save and quit. Let's see what Betty tells us this time. Now you can see Betty doesn't give us any error, but returns back our function, which is print alphabet. So did you understand what just happened? Let me explain again. I did not write main here because our function that we are using is not main. We are using this void print alphabet. This is our function, print alphabet, not main. At other times where we go ahead and we use this, most times what you're used to so far is int, main, and then this, right? But now we are using void for that project and print alphabet, whatever. So that's the reason why in my Betsy documentation here, I have to define print alphabet here. We have no return value whatsoever down here. And so I didn't have to put in a return value. Now you see that Betsy is looking clearer to you, right? So get used to it and make the best out of it. At this point, we can now add commit and push. So let's do that, just that. If you're wondering why I'm not testing my code using the GCC, the reason is because they are going to use we can use our main.c and use it to test our functions, but ALX test case will use their own, main.c file. They would create different test case for it. So there's no need me going to create all these files just to test and test and test. Rather, once I push them to my repo, ALX have their own. So they won't take my own into account. So if I test it the way it is now, it will give me error because I have to create the main.c. I have to create some other files that will give meaning to my program. But ALX is saying I can do that, but once I push my code, those other files I create won't make any meaning. So since it won't make any meaning, there's no need. Let me just go ahead and push it. And if there are errors, I'll use ALX test case to fix them. Git commit -m and then one. So git push. All right, I'm done pushing. So let me go now and test my 1.c. Let's see the moment of truth. All right, so we have a congratulations as all our tests passed successfully, and we can move on to task 2. Now, task 2 is a lot similar. Now, I don't need to go ahead explaining this prototype or what to do with it, or this put chart twice here. But I'm going to explain it again so that you grasp you are able to comprehend very, very well. That's the essence of my tutorial. It's so that you're able to comprehend and make the difficult thing look so easy. Now, let's go. So, this prototype, you know where we are going to copy and paste it in. And in Betty, you know what we are now going to write. We are not going to write main, rather we'll be using this prototype. So let's come here, copy this, and go to our what file? Main.h. Then we come here and paste it. Put our semicolon and we're done. All right. Then I'm going to save and quit my main.h file now. And I'm in task 2, right? So here, when I come now, I just have to, as usual, include my main.h. Right, and in Betty documentation, I could go ahead and write the, so this one, these things I'm doing now, you should be able to do this by now without actually looking at help from anywhere, you know, because these are just like basic requirements. So you know what to write here now. You're not writing main because that's not the function you are using. Look at the function you're going to use here. This print alphabet 10. It's a void function, right? So I'm going to copy this now and just paste it for Betty here so that I don't have any grammatical or spelling errors. So I'm going to paste. All right, so this function would pretty much print 10 times the alphabet in lower case. Lowercase simply means small letter. All right, and how do I know that this function will print 10 times the alphabet in lowercase? See, it's not difficult. Just come here, write a function that prints 10 times the alphabet in lowercase. So you could just copy all of this now and put it as your description. You could be more detailed, or you could be like me that don't like too much details when writing code. Just like going straight to the point. Then down here, so I could use spaces now to pretty much make my work look neat. That's what I'm doing, but you could leave yours like that. Now you know the function we are going to use. It's not our main function, rather it's this one. So why not copy it and after copying it, come here and paste it, or you could just decide to type it out. It's the same thing. And then we move. So now let's talk about the main question. Want to write a function that prints 10 times the alphabet in lowercase followed by a new line. Can you see that this question and question 1 were very simple? Just one thing make them different. The question 1 says you are going to print the alphabet in lowercase followed by a new line. This is question 1. So I'm going to copy this now and paste it here. You know, this is question 1. Now let's go to question 2 and see how similar they are. You see my thought process. When you are given a task, do this. This is what makes or mar you. This is what makes you a software engineer. This is what makes you a problem solver. Compare tasks, look at them again and again, and get the best out of it. So I'm going to come here now and paste this. So now what's the difference between these two tasks? They do the same thing, but this one prints 10 times. So in case this is confusing, I just want you to remove this, like put it in brackets here. Remove it out of the way. So don't read this now. Read every other line between the two, but don't read this. They do the same thing. So are you thinking what I'm thinking? What am I thinking? I'm thinking that writing the same code will help us be 65 or 70% done with task 2, because the two things do the same job. So exactly the way you did it in your tax 1, that's how we're going to do it using a for loop. All right, let's go ahead. A for loop. You remember how we did it that time? Our letter is set to A. So the very first thing we want to do is to set our character to be later. Now, a for loop is set to A, and as long as the later is lesser than or equal to Z, we are going to increment later by 1. Now, this is clear, right? And then we are going to print out char later. Okay, and like we did last time, we are going to print out a new line, followed by a new line. So we are going to print out the new line, and yes, so that should be it. Now, if you notice, you would argue that I'm not following the syntax, and yes, that's deliberate. Now, this is what I want you to do. Pay less attention to the syntax and more attention to understanding what's being done. Now, you could go back to your syntax. You could do this in your for loop now. You could come here and put your brackets. And so this now follows the syntax. So this is exactly what we did in our first tax, in our tax 1. This is exactly what we did. Now, so what's the difference between this and our tax 2? Now go back to your question. The function is going to print 10 times the alphabet. So back to what we just did. As long as the letter is less than or equal to Z, it's going to increment the letter. But now we are going to increment the letter and print it 10 times. So how do we do that? Now we can come up here and create a new variable that would count for us. All right, count. So it's going to count how many times this letter has been printed out. Initially, it's going to be 0 because we don't even have the letters. So we'll set it to 0. Now, come down here and use a while loop. Remember what the while loop does? It looks for something, and while that thing is true, it's going to execute a particular command. So what are we looking for? While counts, while we count 1 time is equal to, is less than or equal to 9, then go ahead with these conditions. So let me get my syntax correct and then I'll explain this. So all our 4 statements now are supposed to be indented properly. So something like this. And then here is also supposed to be indented properly. So you get your indentation wrong, your code, Betty would give you issues, or your code will give you compile problems. And here too is supposed to be indented properly. Yes, so it's now indented properly. So now let's just look at what we've done. We want to print out the alphabet, 10 times the alphabet, right? the count is initially 0. And now, as long as, so initially this alphabet is not printed at all. Now we are going to increment. This while loop says while the increment of the counts plus plus means increase by 1. So while the increment of the counts is less than or equal to 9, while the increment of what we are printing is less than or equal to 9, we are now going to continue with this for loop. So it's going to do for letter A is less than Z. It's going to increment plus 1. It's going to come back. Is that plus 1 equal to or lesser than 9? If yes, it's going to keep incrementing until this A that we have as 1 here is going to now count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You know, if you start counting from 0, which we are counting from, and our letter is A, yeah? If you start counting from 0, you have 9 and not you have 10. So if you start counting from 0, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's count this. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, and this is 10. So here in our code, this A is already 1, but the count here starts from 0. So this A is not even going to count. So after incrementing by 1, it's going to say 0. Then it will increment again. This A will now be 2, but it will now count 1. And so when this A is counting 10, it's going to be 9. When this A is equal to 9, when this A is above 9, you know, we are saying as long as the count is less than or equal to 9. So once this A is above 9, it's going to say the count is not less than or equal to 9. Now it's going to move to our second character, B, and do the same. All in all, it's going to print out our alphabets. It's going to print 10 times the alphabets in lowercase. So we are using this A here and then this Z at the end. So you can see I have a mistake with my Z. I forgot this quotes here. So I'm using the A and the Z in lowercase to print it in lowercase. This line prints a new line, and this put char here print out a single character. I hope this is clear enough. And so that's that. Let's look at Betty now and see what we can. If Betty holds us accountable. Betty doesn't hold us accountable for anything. So we could go ahead and git add, you know, the regular way. Git commit dash m, and I can say tax 2, and then git push. All right. So I've done 0, 1, 2. And if you check your code, it's going to tell you correct. You know, you're going to get the congratulatory message and you deserve it. Now, let's go to task 3. Write a function that checks for lowercase character. Okay, so this function checks for lowercase character. It would return 1 if the character, if C is lowercase. Otherwise, it will return 0. So they gave us the character to use. The character is C. And we are going to check for a function that returns the character. This project is simple. This question is very straightforward. And I hope it doesn't give you a hard time. So let's go ahead and do it together. If you're confident, pause this video now and do it yourself, right? If you have errors, then come back to this video and do it. Or if you are lost and have no idea how to go, then let's go together. And just know this, it's okay to be lost. It's very, 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 very okay to be lost. You know, so don't castigate yourself for being lost. It's normal. Now let's come to, so this is my fourth prototype. You know where I got this prototype from? I'm explaining this in details because moving forward, you're going to see a lot of these questions. So take time and watch it. I hope the video is not too boring or too long that you can't understand. Int is lower C. So this is where I got my prototype from. I just copy it and paste it there. Then I'm going to save and quit VI. Then I'm going to open tax 3. Now insert a regular way. You know the way, so let's go. Include main.h and then Betty. So you know what you should be doing for Betty now. What's the function we are working with? It's lower. This is the function we are working with this time, not the main. So our function is going to check if a character is lowercase, right? And what's our function going to return? So our function is going to return 1 if the character is lowercase. Otherwise, it would return 0. So just say that and move on with life. Let's see the function. We are asked to use an integer type is lowercase here. So let's just go ahead and do that. And so I'm pasting it, no time. Then come here. So how can you check if the function is lowercase? It's a simple thing. Write a function that checks for lowercase. In C, if you want to check for something, how do you do that? Look at the answer looking at you. You remember this statement, if else, right? So let's go ahead and do that. If our character is, now I want you to read this code as I write it. And if you can read it, great. But if you can't, I'm also going to explain it, and don't worry too much. That's normal. You would understand with time. So okay, I hope you read and understood this code well. We are checking for if our character is lowercase. If the character is lowercase, it will return 1. Otherwise, it's going to return 0. So this is it. If C, the value we are giving, is greater than or equal to A. So we are saying any character that is less than A, please, we are not going to look for that character. So if the character is greater than or less than small letter, you can see the A in small letter here, right? This is the first line. And if the character is less than or equal to small letter Z, so if the character is greater than or equal to small letter A, and the character is less than or equal to small letter Z, return 1. Any other thing. So if the character is less than small letter A, or if the character is greater than small letter Z, please return 0. Does it match what we're asked to do, write a function that checks for a lowercase character, return 1 if C is lowercase, 0 otherwise. You're asked to run here, to get what the standard library provides. So you could do that on your own. But basically, that's how to get on with this task. As usual, you want to check for your friend if you have any issues. Oh yeah, we have one issue. It's a warning, and that warning is in line 7. No parameter, no description found for the parameter or member C is lower. All right, so let's go ahead and do the description now. And how do we do that? So we have that issue in line 7. So we are asked to put a description for C. This C here, Betty wants a description for it. Let's go ahead and give Betty the description it wants. So we are going to say this character C is the character to be checked. Now with that, let's see what Betty will tell us if we still have issues. Oh, it still gives us the same problem. It says no parameter found. So let's try something. And let's come here now and use the @ sign to see if we still have that issue. So I'm going to do @C, and then C is the parameter to be checked. Now, let's see if we still have that issue, and no issues anymore. So that was what it was looking for, and I gave it the right input. So we can now move on. Git add, git commit -m tags 3, and then git push. All right, as usual, we are going to check on our code. Don't click done, just check your code, start a new test, and if you're done, the checker would let you know. So let's wait for the checker, and you can see we have our congratulatory message. You have a lot of test cases that you're working with here, and all checked. All right, so great, let's go. Now 3 and 4 are a lot similar. 4 says write a function that checks for alphabetic character. The prototype is going to be this. Returns 1 if the character is lowercase or uppercase, returns 0 otherwise. Too simple, right? If you did tax 3, you understood it. Tax 4, too simple. Let's go ahead and do it, just in case you're still stuck somewhere and doing this. So I'm spending a lot of time giving you this tutorial so that you can understand it, so that you can understand it. And I would really love if you take your time, watch this video and understand it. Remember, there's no shortcut to success. The shortcut is to work hard. And don't mind the length of the video. Just go ahead and go through it. Now let's go to our task 4. So you saw what I did in my main.h there. I just added the prototype. You must add the prototype. Know that. So as usual, if you found this channel to be very helpful in your learning and in doing the tasks, please let me know. Thanks for all the positive comments I get. Let's keep going. So I'm just writing the Betty description. And okay, now it's going to return something, so I'm going to put my return one if character is lower or upper, 0 otherwise. If character is later. So if you like, you could be more detailed in your description, but done with mine. All right. So what's the prototype we're using? I'm just going to copy this, copy, and paste it in here. Now, so what are we going to do? It's still the if statements now. Remember that. So if now we are checking for two things. Go back to your question. It checks for if the C character is a letter, either lowercase or uppercase, return 1. Remember what question 3 was all about. Check for if it's lowercase. That means if it's uppercase, you return 0. But here it says if it's uppercase, still return 1. If it's lowercase, return 1. But if the letter is not uppercase or lowercase, or if it is not a letter at all, return 0. So you remember the if statements. What do you think we can be doing here now? Let's say if the character is greater than or equal to, like we did in the last task, and the character is lesser than or equal to z. But this was what we did in the last task, right? Or you remember what this sign does? This is a or. Why am I using or? Look at it. If the character lowercase or uppercase, so I'm going to use or. Now this is for lowercase. Or if the character is greater than or equal to uppercase A. You see me using the uppercase A now, or the capital letter A. And the character is greater than or lower than Z. So I'm just going to go ahead and show that these two things are the same with these double brackets. So it means that this one still spans up to this one. I just put an or clause in the middle here. So if the character is any of these, oh no, I'm going to come here now. It's going to return 1. Else, any other thing, it should return 0. Does this make sense to you? I guess yes. Very clear, right? So let's go ahead and check our code. And before we check, use Betty to validate. Betty doesn't give us any error, so we are going to git add, git commit -m for, and then git push. All right, so I've git push now. Let me go and check my code. start a new test as always. All right, we passed all the tests. Now let's move on to task 5. I know this is going to be difficult for you, and that's why I'm doing it up to this extent and showing you the way forward. Copy. Now you understand this a lot, so vi main and we paste what we've copied. Oh yes. Now vi5 includes main.h as always, and then okay, so we are looking for print sign, so I'm not going to use that int. I'm just going to do the print sign here. All right, making sense. Our print sign is going to print the sign of a number, and then we're going to do the n, the number to be checked for. So you could go ahead and write a more detailed description and then return 1 if the number. So I'm not, instead of writing this, why not I just copy this? You know, let's just copy that. I come here and paste it. Okay, then here I'm going to remove this other return statements and remove this other one too. Job done, right? Yes, job done. And I think that should be it for my Betsy problems. So, sure you understand what's going on here. In n. Now, look at the question. It says we are going to print the sign of a number. If n is greater than 0, it would return 1 and print plus sign. If n is 0, it's going to return 0 and print 0. But if n is less than 0, it's going to return -1 and print a minus sign. So you are seeing if here. You know you are going to use an if statement, right? So let's go ahead and do that. If n, okay, first I want to do is to put our curly braces, and then if n is greater than 0, did you see that in your tax question? So I'm not punching it from my head, it's there. Then we want to use the put char. Remember, we can't use the printf because we are not using our standard library. Okay, so we want to do this now. Return 1. So if n is greater than 0, print this alphabet. You know how the put char does it now. So simple. And then return 1. Else, if n is 0. Now you can go ahead and complete this, and you want to, once again, so I'm going to copy all of this now, copy and paste it here. Then come here and so if n is 0, the put char is going to, what is it asked to return here? It's going to print 0 as the sign, and then return 0 2. Otherwise, so let me go up so you could see what I'm doing clearly. Now, what's the last condition? If our number is not greater than 0 and our number is not less than 0, it means it's lower than 0. So else, any other thing, want to else, any other thing, we just want to return -1, and here we want to minimize, and here we want to use the put char sign that we already have. And lastly, we want to finish our code. So let's check for trailing white space now. No one in this line, no one in this line, no one in this line. So I'm helping Betty do its checks, and I save and quit. Oh, Betsy 5 9. All right. It says code indents should use tabs where possible. Then in line 21, so we have a lot of line 21, 21, 26, 26. So we have about 2 errors and 2 warnings from line 21 and 26. Now let's move on and solve that. Line 21, here we come. So I'm at line 21. You see line 21 here. And it says, so it says we should use tab where possible. Okay, so I'm going to use tab now, or enter key. See that? Now that's tab. And what other error? I can't remember the other error it gave us. So let's go to line 26. I think it's still the same thing. So I'm going to space out, remove all the spaces, and use tab. That is press enter key instead. Now let me save and quit this and see what Betty says now. Okay, it now gives another error. It says no description found for the return value of print sign. All right, so we are going to do the return value just now. So I missed out something and seriously complaining. In this return, I'm supposed to use this, and I'm not sure it would work. So let's check it with Betty again. Now you see no errors finally. So fix that. So you see Betty is actually simple to fix. Just learn how to do it. And tax 5. Now I want to push to GitHub. If this is going at a fast pace for you, you could rewind it, slow down, change the playback speed. Do everything you need to know to understand what is going on, guys. Just do everything you need to know to understand it. Now let's check for our code if we have any issues or if we are going to be cleared. Well, say congratulatory message, we are all cleared. There's no such thing as absolute value in tag 6. You can only estimate what a thing is worth to you. We are going to write a function that computes the absolute value of an integer. You are asked to run the ABS command. So basically what an absolute value is, it's remove the negative sign and print the positive for us. Okay, so in this function, we are going to compute the absolute value of an integer. In the example message here, they showed us the negative values and then the absolute value of the integer where it's printed out the real sign. So we are going to work with exactly this. We'll print out the negative value and then would also compute the absolute value back for ALX. All right, so let's do just that. And what's our prototype? Now you know how to work with this prototype. Put them in your header files. Copy. I'm going to come here now, vi main.h. Oh, now that's me waiting for the network. And now I can vi into 6, right? Okay, so as usual, we are going to include our header file main.h, and if there's anything you've understood from here is about how to write description and how to go ahead to, you know, header files, Betty. I know you must have understood that, so that's great. Now, if you understand this project as I'm doing it along with you, spending time to explain, that's so nice too. So the ABS computes the absolute value of an integer. So that's what it's going to do now. Value of an integer. The n is the integer we are looking for. The int n question. And then we'll have a return statement. We'll have a return the ABS of the integer. So ABS means absolute value, and absolute value removes the negative and print out the positive. So I want to return the value now in this question, and the want to return the positive value, that is the absolute value, and remove the negative in any case. Now, how do we get the positive value of an integer? Before an integer will have a negative value, so for an integer to have a negative value, the integer is going to be less than 0, right? Because 0 is not a negative value. So it has to be less than 0. So if we have -1, that's less than 0. If we have -2, that's less than 0. So all these are negative values. An absolute value, if you have a -1, absolute value is going to get you a 1. All right, so let's write the code to check for the values that would help us return absolute value. So let's go int abs. Abs means absolute value. All right, if the n, now the n is the is the value in question, right? Now, if the value is equal to or less or greater than 0, it means then it's going to return return the absolute value of that n, right? Now, else, that is if the value is not equal to or greater than 0, it will not be able to return the absolute value, but instead we are going to tell it to return the value and its negative sign. All right, so using this code now, we can check for all the numbers with their absolute value, and once we get a number that is greater than or equal to 0, we get the absolute value immediately. So that's how simple that task was. And I want to check my main.h file again, and you can see it here. Oh, we've not printed the ABS, so I've not added that in my, you can see I almost forgot that, and that would have given me a lot of issues. So I'm going to copy this and paste it here. So please don't forget to put your prototype here. I paste this, and oh yes, now let me use Betty to look for file 6 and see if Betty has any error. Yes, Betty gives us an error in line 13. You can see it here, line 13, error trailing white space. So let's go and fix that up. Line 15, line 14, and line 13. Oh yes, so I've removed the white space, and let's check Betty again. No white space. Okay. Now we can git add, git commit with tax 6, and then git push. All of this. Now let's check our code just to be very sure, so that you know, the moment of truth, everybody's silent. We're just waiting patiently for the checker. You have that feeling a lot. But once you're doing the right thing, you really don't have anything to be worried about. Don't worry if you are getting issues. It's normal. You have to do these things again and again and again and again before you master them. It's perfectly fine. Keep putting in the effort and you get it. Oh yes, you have 11 advanced questions, and I've taken you through 6 of them. You don't have 11, you have 12 advanced questions, and I've taken you 6 of them. So now you have 7, 8, 9, 10, 11. You have 5 advanced questions to answer now. I've taken you through 7 of them, from 0, 1, 2, 3, 4, 5, 6. About 7 advanced mandatory questions, rather, not advanced. 7 mandatory questions. I've taken 7 of them, and now you have remaining 5. I want to ask you this question.
Try now. I don't try. I don't try. I beg when I talk. If I don't try, when I talk now, when I don't say, I try, but I don't try. Please.
I've tried a lot. I've explained every bit of it. Now you know where to put this. You put this in your main.h file, and then you copy this. This would be your main, where you are supposed to write int main void. This is what you put there, and then you are going to print the last digit of a number. Remember how we did that? Can you remember how we did that? In my last class, I talked about printing the last digit of a number. Can you remember how we did that? You print the last digit of the number using your modulus operator. So go ahead, get that right. And then you're giving examples here. From all the things I've said, you should be able to do the rest questions. But if you are not able to do it, I understand. That's why I'm giving you this GitHub page now. Come to GitHub and search for BWave ICT or search for Bright on GitHub, you would find me. Please click on the follow button, and here you would see my repository. Just click on ALX low level programming, look for what you're looking for here, and look for the tags you need. You know, if it's tag 7, tag 8, anything, look for it. You can compare codes with my own. You can open it, compare what I did with where you are having errors, and make the best out of this. Thank you so much, guys. Thank you once again. This is B-Wave teaching, making it look as simple as it can be. But there's one more thing. You can join my special intense learning class, you know, right? Join it and let's take C from scratch. C programming from scratch. Let's make it look like the child's play that it is. Thank you once again, and until next time, goodbye.